All right, ladies and gentlemen. So today we're going to be working with exponents. Okay, you guys have worked with exponents a little bit already. Okay, you know what a square is, right? I mean, if I say 5 squared, what is that saying to you? 5 times 5, right? It's not 5 times 2. Okay, right? 5 squared, what I'm saying is 5 times 5. Okay, I remember a story when I was first starting to teach. I was 32 years old when I started to teach, and students would walk up to me and say, "Mr. Ronco, how old are you?" And I would say, "Well, I'm 2 to the 5th." Because that's 2 times 2 times 2 times 2 times 2, right? And then later on, when we get to this unit, invariably, I write this on the board, something like it, and some kid tells me that the answer is 10. Okay, guys, I'm not 10 years old. Okay, all right. So I wanted to multiply 5 times 2. I already know a way to multiply 5 times 2. It's like this. I don't need a new way to multiply 5 times 2, okay? But this is shorthand. It's mathematical shorthand. It's a fast and easy way of writing. Okay? That's the whole idea, is that exponent is the number of times that you write down whatever is at that exponent's ankle. Okay? So if I have negative 3 to the third, notice that I'm putting that thing in parentheses because I want to say negative 3 times negative 3 times negative 3. Okay? The whole thing is multiplied by, so that times negative. By the way, is my answer going to be a positive or negative number? Ooh. Right, okay, because remember, negatives destroy each other in pairs. Okay? The first 2 negatives, and then it'll be a positive. So 3 times 3? 3 times 3 times 3 is what? 27. Is my answer positive or negative?
Take it down one at a time. 3 times 3 is 9, so it's 9 times 3. Everybody knows 9 times 3.
Right?
We've been working with this.
Okay, so now dealing with it with, hard numbers isn't that bad because all you're doing is just doing lots of multiplications all the time. Okay? But it's when we start throwing in variables that students kind of start getting a little itchy and wondering what the heck is going on. But let me explain what we're doing. All right. If I have x to the third, what this is really saying is x times x times x. Okay? It's just shorthand because if I were to write down x to the 20th, okay, there's a whole lot of x's here, and I don't want to write them all down. You know what I mean? And besides, if I were to write down 20 x's all in a row, it might be hard to count them without losing track, I mean, have you ever tried doing something like that? It's like, for example, even something as simple as, in this room there aren't too many of them, but okay, like for example, if I asked you to count up the number of bricks in that wall, okay, those bricks are pretty big, but even after a little while, you sometimes get lost, okay, especially if you have, like if I said this, how many lines are there? You see, it's not so easy to count them all up like that, and that's one of the reasons why when we write really, really, really big numbers, even something like that, if we were to actually have that number on our paper, a lot of times what we do is we put a comma in there so that we break it up into groups of 3 because it's kind of weird to add, it's kind of hard to add up a lot of identical things in a row. Okay, so when we write exponents, what we're doing is we're trying to write a lot of information in a small little space. Does that make sense? Okay. So, if I have x to the third times x squared, okay, now what's happening here is I've got 3 x's in the first guy. See? I have 3 x's in the first guy, and I've got how many x's in the second one? 2. So altogether, how many x's do I have? So how did I make that 5? I added what? The 3 and the 2. I added them up, right? So if I had if I asked you for x to the 5th times, how many would that be? I have 15. I get 5 from the first batch and 10 from the second batch. Make sense? Okay.
Instead of having to write all of them out.
Yeah, that's a lot of work. Okay. So that's the first of the 2 rules we're going to be working on today, because I want to get you guys up on the boards working in these problems quickly. We're going to have one more rule. There are other rules that we're going to talk about. We're going to do that on another day. All right? The next rule we're going to talk about is when you have an exponent like this, a power to a power. Okay? So now what we do here is we go from the outside in. And we say, this 2 is saying whatever's at my ankle, and in this case it's a pair of parentheses, I'm going to write that pair of parentheses 2 times. Well, everybody's multiplied together, so I don't need to worry. I can drop my parentheses now. And I get x to the 3rd. So altogether, how many x's am I going to have in this problem? How many? I get how many from the first batch? And how many from the second batch? Altogether, how many do I have? 6. What happened with my exponents? What happened? I multiplied them. I have 2 groups of 3. You see? How many do I have there? How many? I got 1? How many? 15. That's a whole lot of work. Believe me, if I can do this in less energy than writing out all of it. But if in your mind's eye, you can say to yourself, I've got 3 groups of 5. Right? 3 groups, and each group has 5 things in it. So altogether, I have 15 of them. Okay? What about this? $15. Oh, sorry. I didn't write it down. Thank you. Okay. Pencils all good? All right. We're throwing in 2 variables. Okay. So let's look at this and say to ourselves, what's going on? I've got a power to a power and another power to a power. So what do you think is going to turn this guy turns into? How many x? If I have 2 groups of 3 x's, how many x's am I going to have? 2 groups of 3 is 6. How many y's am I going to have now? Yeah, because I have 3 groups of 3. See what I'm talking about? Is this okay? Not so bad? How about... Okay. Now you got to watch out. This is the kind of problem you're going to be seeing today. Okay? What we have here is x to the 1st. If you don't see anything written there, it's to the 1st. And this number is to the 1st. Okay, that might help you. If you see just a plain old number all by itself or a plain old variable by itself, There's times, so that's why we put an exponent of 1.
Everything has a variable. Everything has a variable.
Exponent.
I mean an exponent. So if it has none, you have to put 1. Right? Put 1 there to make it easy for you.
Okay. So this guy, this x squared, we're going to hold off on him. Because my order of operations tells me I got to do parentheses first. I can't deal with that x squared because he's dealing with multiplication. I got to deal with that exponent and that parentheses before I go anywhere. Okay? So we'll deal with him last. So now, what's going to happen with this 4? What's the 4 going to do when it goes? How many 2's am I going to have now? How many 2's? 4, because it's going to be 4 times 1, right? And 4 times 1, x to the 4th. And how many y's? Okay? So, dealt with my exponent. I've got nothing to do inside the parentheses anymore. I'm good. Now, drop my parentheses now because I'm not having to deal with, there's nothing else going on in there and everybody's multiplied. So, how many x's am I going to have all together in this thing? How many?
6.
Why 6? You're right, but why 6?
Because you have x plus x.
Well, how many x's do I have from this guy? And how many x's do I have from this guy? 4, right? So I've got a group of 2 and I got a group of 4, and they're all going to get mixed together. Does that make sense? So all together in this big pot of variables, I'm going to have a group of 4 and a group of 2. They're going to mix together. We get 6 of them. You are missing out on the best part of this lecture. Come back anytime this block, if you can. Yeah, because it's got some good stuff left. Okay, 2 to the 4th. What is that saying? What is that, 8? What is that? 2 to the 4th. What is that, 24? What is that? It's 2 times 2 times 2 times 2. Yeah, how many 2's is it? So what's 2 times 2 times 2 times 2?
2 times 2.
Y still there? And now we usually put our whole numbers, our coefficients, in front. And now you're done. Okay? I don't care about alphabetical order. That's not important. You know, the order of the variables isn't important. But we usually put the whole number piece out in front. Okay? You want to do one more before you hit the boards? Good. This one's got layers to it. So let's work it from the inside out. Okay? So, we got 2 to the 1st. And this 3 is going to go here, and it's going to go here.
We're getting rid of a layer, right? We're getting rid of that first layer.
We're cleaning it up.
Dropping those parentheses because we're distributing it. Right?
So what does that 2 to the 1st to the 3rd power mean? What's that going to be? 2 to the how many?
3.
2 to the 3rd, and what's that? 2 times 2 times 2.
Times 2.
4. 8. 8 more.
Okay. And how many B's?
9.
Okay, good. So now, how many inside the parentheses, how many B's do I really have?
13.
You see why it's 13? Because I got 9 in the first group and I got 4 in the second group. And when I mush them all together and I throw them all in the same big pot, I'm going to have a total of 13 B's. Okay? And now, what's that going to be? 8 to the second. When what's 8 to the second? That's 8 times 8, so that's 4. And how many B's now? And now we're done. You know you're done when you're left with a single whole number and one of each letter. Okay? Or each letter written only one time. Oh, you really don't want me to wake you up. That is generally not a good thing. Okay. One more?
So,
Yeah, those are A's. Oh, I actually have them all up here. Okay. So, first on it. Okay. And it's -1b. Okay. So, -1 cubed. That's -1 times -1 times -1. It's going to be what? How many? B to the how many? 3 groups of 3, right? See why it's 3 groups of 3? Let's deal with my whole numbers. -1 times -2. Right! You guys are on top of it. How many B's altogether are in this thing?
6.
I got a group of 3 on one side, and I got a group of 3 on the other.
is there a parenthesis? So why are you multiplying? We don't multiply in the parenthesis. So what are we doing with the add them?
You add them, because it's really saying B times B times B. So how many B's altogether? 6 B's. Or B to the 6. How many A's? How many A's? I got 9 right here,
12.
and 3 here. So how many A's?
12. Yeah, 12.
12. Did I fall?
Yeah. We took out this point for it. Perfect.
See? Booby trapped. Okay. You guys ready?
Yes, sir.
All right, here we go.
Okay, let's hit the boards. This episode of the Ronco Show has been brought to you by the properties of Exponents.